Boise State University owns a solar charging hub that resides near the library. This system enables students to charge their devices such as cell phones and laptops using a green energy source. The system doesn't provide data on the amount of power being consumed by the user or the amount of power that the solar panels are producing. We, the Solar Charging Hub team, have developed a new system that will allow for these readings, and they will be displayed for students and anybody using the device to see. Hello, my name is Morgan Brimstein. I am on the Solar Charging Hub team. My contributions to the team included a lot of the documentation and also the communication between the current Sense board and the Raspberry Pi using I2C and Python.
My name is Chris Covert, and I'm in charge of the Solar Hub part selection and designing the GUI web interface that's going to be used for the Raspberry Pi screen. And I'm also editing this video right now.
I'm Keith, I'm the team leader. I worked on the current Sense board, I'm working on the web interface, the logging software. I did any of the 3D design for the stuff we 3D printed, and as the person with the crimper, I'm the crimp master.
As engineers, our group knows that good decisions are driven by data. The upgrade we built helps to provide that data for the Solar Charging Hub. The new system has an external screen displaying the instantaneous power consumption and production, as well as daily energy savings. And that data isn't just displayed, it's logged to a website that allows seeing a comparison of generation and usage over the seasons.
Time to define the device on the bus. The computational work is handled by a Raspberry Pi. It uses its built-in I2C interface to talk to the chips on the current Sense board. The board was connected to the Raspberry Pi, and the built-in functions were used to scan for I2C devices. With connectivity confirmed, a script was written in Python to enable the Raspberry Pi to gather data from the current Sense board and calculate the power, which could then be uploaded to a logging server.
The core of the system is the current Sense board we designed. It uses two Texas Instruments power measurement ICs that can measure current drawn down to the milliamp, even while still allowing currents over 80 amps with no changes in configuration. Of course, you don't want to be running 80 amps over just any PCB, so instead the current passes through industrial-grade, high-precision current shunts, and only the differential voltage across them goes to the board. After many trials and tribulations getting another solar logging package to work with our custom-built board, we ultimately shifted over to using the logging software created by the Open Energy Monitor project. This open source server can run directly on the Pi and communicates almost entirely through simple HTTP requests. This allowed us to easily interface with the Python script collecting the data, and we can even back up the data to the cloud in case of hardware failures. This is where the real advantage of using the Raspberry Pi comes in. It has more computing power than is strictly necessary, but because it runs a full Linux operating system with all that entails, there are an incredible number of ways we can use the data once it's collected. We're also able to use this to drive the interface of our physical display.
Since the enclosure will be kept outside, it had to be made to withstand all of Boise's weather conditions, including snow, rain, and hail. To account for this, an IP65 rated weatherproof enclosure was to be installed. The cables connecting the devices are sealed using cable glands, while the bare LCD module is mounted using 3D printed spacers that go quite nicely with the Boise State colors.
Ultimately, the data that comes from upgrading the Solar Charging Hub will be used to drive decisions about how viable it is to install more solar energy systems on the Boise State campus, while also allowing the user to see the steps that Boise State is taking to provide more green energy. Already there are plans to add a much larger solar bar in the hope that the knowledge gained from upgrading this existing solar hub and the data gathered from the upgrades will go into making a more efficient and larger model.